Exercise 6, our second exercise, calculating molar mass. Calcium carbonate. Again, this is the name of something. It's called this. You may think, oh, I have to know what that is. No, you don't. The vast majority of AP problems will name something and then give you the formula. It's also called calcite. If you've ever heard of calcite as a mineral, right? It's very important to ocean water precipitation reactions, sedimentary rock, more of a physical science thing, but different names for the same stuff depending on what field you're studying. But since we're doing chemistry, calcium carbonate, hope you recognize that the CO3 is the carbonate anion. Anywho, this calcium carbonate is the principal mineral found in limestone, marble, chalk, pearls, and the shells of marine animals such as clams. I don't care right now. I care about passing the AP exam. Calculate the molar mass of calcium carbonate. That's this. So there's 1 calcium, there's 1 carbon, and 3 oxygens. So let's make sure we know what the molar masses here are. Now, I remember that oxygen is 16. I remember that carbon is 12.01. Maybe I don't remember what calcium is. So I'm going to go to the periodic table. I'm going to go to 2 places past the decimal, so that'll be 40.08. 40.08. Again, remember, you will have access to a periodic table on the AP exam. It's going to be printed on the booklet. You don't even have to bring your own. And so you just have to look it up. So let's do the calculation like we did last exercise on the calculator. So I'll go 1 calcium, so it was 40.08, plus 1 carbon, and 3 oxygens. So let's plug this into my calculator here. 1 times 40.08 plus 1 times 12.01 plus 3 times 16.00. Come up with 100.09 grams per mole. Let's see. 2 places past, 2 places past. That's what I was checking. So I multiplied. Remember, order of operations, multiplication happens first, then the addition happens. I'm adding 3 numbers that are going to have 2 decimal places. So I'm going to report my answer with 2 decimal places in my answer. All right, B. Now, as you've seen in the previous exercise, and then we're just about to do this in this exercise, a lot of the longer free response questions on the AP exam will lead you. You'll have to use the answer you calculate in A to calculate your answer for B. Then you have to use that answer from B to calculate your answer for C. Or you might have to combine the numbers you get in A and B to get your value for C. But the AP problems typically lead you towards what they want you to do in a kind of order. So a certain sample of calcium carbonate contains 4.86, that's 3 significant figures, by the way, moles. Calculate the mass in grams of this sample. Well, in exercise 6, we found that if we're going from moles to mass, we need to use the molar mass, which is the grams per mole. Well, good for us. Guess what? We just calculated that. So we're going to start with the 4.86 moles. Set up our conversion factor. Moles is going to be on bottom so that they cancel. That'll leave grams on top. And what is it? 100.09 grams. And let's calculate. 4.86 times 100.09. Again, I wanted 3 significant figures, so right there, that 4 tells me to keep it the same, so 486 grams. 486 grams. Now, let's be really, really careful here, because B actually has 2 questions, and so if this was the AP exam, there would be 2 points available for portion B, which is fairly common that you can earn multiple points on one specific question. So we have calculate the mass in grams of the sample, then calculate the mass of the carbonate ions, the CO3 minus 2 ions. What's the mass of that? So we have 2 different calculations to do here. Now, this might seem like a very, very difficult question. This is one of those situations where it's very, very simple. We have to keep our heads on straight and think through. Nothing good will come of you freaking out or fretting, right? Fret not. Fret not. How many, what's the mass of the carbonate present in this same sample? So we have 4.8 moles of this stuff. How do I know that there are 4.8 moles of carbonate? Because there are 4.86 moles of calcium carbonate. And notice there's 1 calcium for every 1 carbonate. For every 1 calcium carbonate, the whole stinking thing, there's only 1 carbonate. It's a 1-to-1 ratio. For every one formula, there's 1 carbonate. It's 1-to-1. So if there are 4.86 moles of calcium carbonate, there's 4.86 moles of carbonate. Now I'm going to set up a conversion factor very similar to the way I set it up already in the first part of this problem, so that moles cancel and I'm in grams. But instead of plugging in the molar mass of calcium carbonate as a whole, I'm only going to target the carbonate, which would actually be this portion of this first calculation right here. So let's add it up again. There's 1 carbon. There are 3 oxygens. So our molar mass is 60.01. Right? Let's calculate that. So 60.01 is already in my calculator, so I'll multiply that by the 4.86. And I come up with the 291.6486, bunch of calculator vomit. I still only want 3 significant figures, so I'll keep it to that 1. That 6 tells me to round it up, so I'll report 292 grams of carbonate.